On today's battlefield, innovative technology can extend soldiers' tactical situational awareness, especially inside complex terrain or caves, mountains, or even buildings that would otherwise be costly, impossible, or deadly to achieve. ARL and University of Pennsylvania researchers are essentially taking commercially available technology, such as the quad rotor, and outfitting it with advanced intelligence systems like miniature sensors, cameras, and communication devices to allow them to navigate and carry out complex missions.
The focus at UPenn in particular is on both air and ground platforms, the small, we're aiming at micro platforms ultimately, but small type platforms, especially that are collaborating. So we have multiple platforms that are collaborating. We're focused on trying to do things like surveillance in and around buildings is a particularly challenging scenario that we focus on. So we want to support the warfighter in those challenging environments where he has limited ability to go in and out. It may be very dangerous for him, and he'd rather work with robots. So we look at problems like mapping, communicating, other collaborative type tasks.
Army officials anticipate that this project will lead to robust integration of robots that can go into buildings ahead of soldiers to ascertain threats from other humans, weapons, or explosives.
So when you think about aerial or ground vehicles, our role is really to provide the brains for these vehicles, the ability to think, the ability to look at the environment, to reason about the environment, and to figure out how to act so that you want to produce the necessary action to fulfill commands issued by, let's say, a soldier.
Army and university researchers are expanding the capabilities of quad rotors, or vehicles lifted and flown by 4 rotor blades. The quad rotor is maneuvered by adjusting the relative speed of each of the 4 rotors. Unlike standard helicopters, the blades on quad rotors are fixed pitch.
So this is a small, agile aerial platform that can exhibit the kinds of behaviors that we need in mass platforms. That is, for example, go through windows, enter buildings, 3-dimensional environments like the kind that you see here, go underneath tables, perhaps go perch on windowsills, listen, see, observe, communicate back to the soldier. So that's what this little this quad rotor can do. So this claw was specially designed and fabricated here. This allows these quad rotors to perch, for example, on windowsills or go pick up objects.
The Army hopes to introduce a network group of small vehicles and sensors operating in dynamic adversarial environments where there may be few soldiers with limited resources and supporting systems.